Today, we'll be talking about the integration of sine and cosine. So first, let us start with sine or cosine with odd exponent. Let's try the integral of sin³ of x dx. So, first thing you're going to do here first is to factor out 1 sin of x. And transform sin²x into its trigonometric identity, which is this. So this should be the integral of 1 minus cosine² of x multiplied by sin of x dx. So let u here be cosine of x. And so derivative of cosine of x would be negative sin of x dx. And so substituting it, we would have the integral of 1 minus u squared sin of x dx right here is equal to du. But since it is negative, this would be negative du. We can put the negative sign outside the integral. And so, by integrating this, we would have the integral of 1 du would be u, and the integral of u squared would be u to the power of 3 over 3 plus c. Distributing this negative sign, we would have negative u plus u to the power of 3 over 3 plus constant of integration, and substituting u back into its original form, which is cosine of x, the final answer would be equal to negative cosine of x plus cosine cube of x over 3 plus c. The integral of sine to the power of 5 of x dx. So, once again, factor out 1 sine of x. And we need this to be equal to sin² of x. So, this would be integral of sin² of x raised to the power of 2 multiplied by sin of x dx. And so, we will transform sin² of x again into its trigonometric identity, which would be 1 minus cosine² of x. And so, let u here be cosine of x, and derivative of this once again would be equal to negative sin of x dx. And so this would be the integral of 1 minus u squared raised to the power of 2 sin x dx. This would be negative du. Just put negative sign outside the integral. And so, next step would be to expand this expression. So this would be 1 minus 2u squared plus u to the power of 4 of du. And so, integrating this one by 1, the integral of 1 du would be u. The integral of 2u squared would be equal to 2u to the power of 3 over 3, and the integral of u to the power of 4 would be u power of 5 over 5 plus c. Distributing the negative sign, And so, let us substitute back u into its original form. So, the final answer would be negative cosine of x plus 2/3 of cosine to the power of 3 of x minus 1/5 of cosine to the power of 5 of x plus c. The integral of sine to the power of 7 of x. So, factor out 1 sine of x again. And to get sine squared of x here, and transform this to its trigonometric identity. And so, let u here be cosine of x again. Derivative of this would be negative sine of x dx. And so this would be negative integral of 1 minus u squared to the power of 3 of du. Expanding this, we would have 1 minus 3u squared plus 3u to the power of 4 minus u to the power of 6 of du. And so integrating this, we would have u minus integral of 3u squared would be 3u to the power of 3 over 3 plus integral of 3u to the power of 4 would be 3u to the power of 5 over 5. And the integral of u to the power of 6 would be u to the power of 7 over 7 plus c. And so distributing the negative sign, there. No? Let's put u back into its original form. And so the final answer would be negative cosine of x plus cosine cube of x minus 3/5 cosine to the power of 5 of x plus 1 over 7 cosine to the power 7 of x plus c. The integral of sine to the power of 9 of x dx. So once again, factor out sine of x. And get sine squared of x in here. And to transform this into its trigonometric identity, and so let u here once again be cosine of x. Derivative would be negative sine of x dx. So substituting this, we would have negative integral of 1 minus u squared to the power of 4 of du. Expanding this expression, we would have negative the integral of 1 minus 4u squared plus 6u to the power of 4 minus 4u to the power of 6 plus u to the power of 8. Just in case you don't know how to expand this, Just multiply 1 minus u squared to the power of 2 together, which would be 1 minus 2u squared plus u to the power 4. And multiply this by 1 minus 2u squared plus u to the power 4. By multiplying this together, you should have this answer. So, integrating this, we would have u minus 4u to the power of 3 over 3 plus 6u to the power of 5 over 5 minus 4u to the power of 7 over 7 plus u to the power of 9 over 9 plus c. Distributing the negative sign, and substitute u back into its original form. So the final answer would be negative cosine of x plus 4 over 3 cosine cube of x minus 6 over 5 cosine to the power of 5 of x plus 4 over 7 cosine to the power 7 of x plus 1 over 9 cosine to the power of 9 of x plus c. Let us now start with cosine cube of x dx. And so, just like sine, just factor out 1 cosine of x here. And so, since we already have a cosine squared of x here, we shall transform this into its trigonometric identity, which would be equal to 1 minus sine squared of x. And so, let u here right now be sine of x. Derivative of sine of x would be equal to positive cosine of x dx. And so, substituting this, keep in mind that this is now positive, so there will be no negative integral here. So this would be integral of 1 minus u squared du. And now, integrating 1 minus u squared, the integral of 1 would be u, and the integral of u squared would be u to the power of 3 over 3 plus c. And so, substitute back, we would have sine of x minus 1/3 sine cube of x plus c. The integral of cosine to the power of 5 of x dx. So, once again, factor out 1 cosine of x. And so, we must have this in the cosine squared of x form. And transform cosine squared of x to its trigonometric identity. So this would be integral of 1 minus sine squared of x raised to the power of 2 multiplied by cosine of x dx. And let u here be sine of x. Derivative of sine of x is cosine of x dx. So this would be integral of 1 minus u squared raised to the power of 2 of du. expand this binomial expression. So we would have the integral of 1 minus 2u squared plus u to the power of 4 of du. The integral of 1 du with respect to u, is u. And the integral of 2u squared would be 2u to the power of 3 over 3. The integral of u to the power of 4 would be u to the power of 5th over 5 plus c. And put back u. So the final answer would be sin⁵x minus 2/3 sin³ plus 1 over 5 sin to the power of 5 of x plus c. The integral of cosine raised to the power of 7 of x. So, factor out 1 cosine of x again. So, we must have this in cosine squared of x form. And transform this into its identity. And now, let u here once again be sin⁵x. Derivative of this would be cosine of x. And multiply this by dx. And so this would be integral of 1 minus u squared to the power of 3. Just in case you don't know, du here is cosine x dx, which is this. So just substitute it as du. And now expand this trinomial expression. So this would be the integral of 1 minus 3u to the power of 2 plus 3u to the power of 4 minus u to the power of 6 of du. The integral of 1 du would be equal to u. Integral of 3u squared would be 3u to the power of 3 over 3. Integral of 3u to the power of 4 would be 3u to the power of 5 over 5 minus integral of u to the power of 6 would be u to the power of 7 over 7 plus c. This 3 would cancel. And so, by putting u back into its original form, we would have sin⁵x minus sin⁵x plus 3/5 sin to the power of 5 of x minus 1 over 7 sin to the power of 7 of x plus c. The integral of cosine to the power of 9 of x. Factor out 1 cosine of x again. And put this into its cosine squared of x form. By the way, just in case you don't know how to do it, if you put cosine squared of x and raise it to the power of 4, 4 times 2 would be equal to 8. So that's that. And so, transform this into its identity once again. And let u here be sin⁵x. Derivative of sin⁵x would be cosine⁵x dx. And so we would be having the integral of 1 minus u squared to the power of 4 of du. Expanding this expression, we would have the integral of 1 minus 4u squared plus 6u to the power of 4 minus 4u to the power of 6 plus u to the power of 8 of du. And so integrating this one by one, integral of 1 would be 1 du would be u minus integral for this would be 4u to the power of 3 over 3 plus the integral for this would be 6u to the power of 5 over 5 minus 4u to the power of 7 over 7 plus integral of u to the power of 8 would be u to the power of 9 over 9 plus c. Thus, the final answer would be sin⁵x minus 4/3 sin³ plus 6 over 5 sin to the power of 5 of x minus 4 over 7 sin to the power of 7 of x plus 1 over 9 sin to the power of 9 of x plus c. Let us try this example. If you are dealing with mix of sine and cosine of x, so if you see an odd exponent amongst these two, this one is even and this one is odd. If you even see one odd exponent, you must choose this and use the odd exponent rule. And so this would be integral of sin² of x. And since this is on the odd exponent rule, we will factor out 1 cosine of x. And put this in the form of cosine² of x. And now, let u here be, I forgot, we must first transform this cosine² of x into its trigonometric identity form. And so, let u here be sin⁵x. Derivative of sin⁵x would be cosine⁵x. And so, by substitution, we would have sin² of x, it would be u squared multiplied by 1 minus u squared to the power of 2. This should be cosine x dx multiplied by du. So first, let us expand this. So this would be u to the power of 2 multiplied by 1 minus 2u squared plus u to the power of 4 of du. And distribute u squared into this 3. So this would be integral of u squared minus 2u to the power of 4 plus u to the power of 6 of du. And so let us integrate this. Integral of u squared would be u cubed over 3 minus integral of 2u to the power of 4 would be 2u to the power of 5th over 5. And the integral for this would be u to the power of 7 over 7 plus c. Thus, the final answer would be 1/3 sin³ of x minus 2 over 5 sin to the power of 5 of x plus 1 over 7 sin to the power of 7 of x plus c. The integral of sin³of x cosine to the power of 4 of x dx. And so, this one is even and this one is odd. So, we must focus on sin⁵x. And so, by applying the odd rule exponent, this would be sin²x multiplied by sin⁵x. And so, transform this into this identity. So this would be integral of 1 minus cosine²of x sin⁵x. Let's just rearrange this. So this would be cosine to the power of 4 of x multiplied by sin⁵x dx. And so, let u here be cosine of x. Derivative of cosine would be negative sin⁵x dx. And so, by substituting, we would have 1 minus u squared cosine to the power of 4 of x. It would be u to the power of 4 sin⁵x dx. Since it is negative, it would be negative du. We can just put the negative outside. And so, distributing u to the power of 4 in these two, we would have u to the power of 4 minus u to the power of 6 of du. Integral of u to the power of 4 would be u to the power of 5 over 5. Integral of this would be u to the power of 7 over 7 plus c. Distributing negative, we would have negative 1 over 5 u to the power of 5 plus 1 over 7 u to the power of 7. Final answer would be negative 1/5 of cosine to the power of 5 of x plus 1 over 7 cosine to the power of 7 of x plus c. Integral of sine to the power of 4 of x cosine³ of x dx. Since this is odd, we must focus on this one. So this would be sine to the power of 4 of x and factor 1 cosine of x here. And transform this into this trigonometric identity form. And now, let u here be sine of x. Derivative of sine of x would be cosine of x. Multiply this by dx. So this would be integral of u to the power of 4 multiplied by 1 minus u squared du. Distributing u to the power of 4, it would be u to the power of 4 minus u to the power of 6 of du. Integrating this expression, we would have u to the power of 5 over 5 minus u to the power of 6 over 6 plus c. The final answer would be 1/5 sine to the power of 5 of x minus 1. This should be u to the power of 7 over 7. 1 over 7 multiplied by sine to the power of 7 of x plus c. So, let us now talk about even exponent regarding sine and cosine. So, let us start with the integral of sin² of x dx. So, we will transform this into this trigonometric reduction formula, which would be equal to 1 minus cosine twice of x, but since our x here is x, so it is just 2x. Just in case you are dealing with something like sin² 2x, this would be equal to 1 minus cosine 4 of x, because it is twice the value of x, over 2 of dx. So, we can put 2 outside the integral. So, this would be 1/2 the integral of 1 minus cosine 2x dx. And so, let u here right now be 2x. Derivative of 2x is 2. Multiply this by dx. And so, dx right here would be equal to du over 2. And so, this would be 1/2 the integral of 1 minus cosine of u. Dx right here would be equal to du over 2. We can put outside again the 2 here. So, this would be 1/4 the integral of 1 minus cosine of u of du. And so, let us now integrate this. Integral of 1 du is simply u. And the integral of cosine of u, it is equal simply to sin u plus c. So, the final answer would be 1/4 u here is 2x minus 1/4 sine of 2x plus c. Or you can just put it like this. Since 2 and 4 will divide each other, this would be equal to 2. So, it would be x over 2 minus 1/4 sine of 2x plus c. The integral for sine to the power of 4 of x dx. So, we must put this into sin² of x form. And transform this to its identity. Wait, not identity, I mean reduction formula, So, this would be 1 minus cosine of 2x over 2 raised to the power of 2 of dx. And so, the next step here, we can rewrite this as 1 minus cosine of 2x raised to the power of 2 over 2 raised to the power of 2. This is what the raised to the power of 2 there means. So, 2 squared right here would be equal to 4. And now, we can put 4 outside. So, this would be 1/4 the integral of 1 minus cosine of 2x raised to the power of 2 of dx. And so, we can first expand this. So, this would be 1/4 the integral of 1 minus 2 cosine of 2x plus cosine squared of 2x of dx. And so you can see here, the exponent of this is even. So we will use this now. So this would be 1/4 the integral of 1 minus 2 cosine of 2x plus cosine squared of 2x. Rewrite this as 1 plus cosine of twice of x, which is 2x over 2. 2 multiplied by 2x. This would be equal to 4x. And so, we must simplify this. We can rewrite this as 1/4 the integral of 1 minus 2 cosine of 2x plus 1/2 plus cosine of 4x over 2 dx. And so, we can add 1 and 1/2 together. One plus 1/2 would be equal to 3 over 2. Now, we can split this integral apart first for simplification. So this would be 1/4 the integral of 3/2 of dx minus 1/4 the integral of 2 cosine of 2x dx plus 1/4 integral of cosine of 4 of x over 2. Wait, actually we can just put 2 outside now. This would be cosine of 4x. And since we will be multiplying this by 2, this would be equal to 8 of dx. So let us first focus on this one. And so, let u here in this case be 2x. Derivative of 2x would be 2 dx. And so dx right here would be equal to du over 2. And so this would be 2 cosine of u. Dx right here would be equal to du over 2. These two will cancel each other out. So you are left with here is cosine of u du. And so, let us now focus on the other one, cosine 4x dx. For this one, let us use another variable. Let a here be 4x. Derivative of a, which is 4x, is 4 dx. So, dx right here would be equal to dA over 4. And so, this would be cosine a dx right here would be equal to dA over 4. And so integrating this, integral of this one, this would be 3 over 8 of u, x, minus 1/4 integral of cosine of u is simply sine of u plus 4 multiplied by 8 here would be equal to 1 over 32. Integral of cosine of a would be sine of a plus c. we will substitute the variable back. And so the final answer would be 3x over 8 minus 1/4 sine u here is equal to 2x plus 1 over 32 sine of a, which is 4x plus c. The integral of sine to the power of 6 of x dx. So first we must put it in the sin² of x formula. Cube of x dx. And so we will transform this now. So this would be 1 minus cosine 2x over 2 raised to the power of 3 of dx. And so rewrite this as 1 minus cosine 2 of x to the power of 3 over 2 raised to the power of 3, which is 8. And put 8 outside. So you will have 1/8 integral of 1 minus cosine of 2x raised to the power of 3 of dx. And so we can expand this. This would be 1/8 integral of 1 minus 3 cosine of 2x plus 3 cosine squared of 2x. Integral of sine to the power of 6 of x dx. So put it in the form of sin² of x first. 2 divided by 6 would be 3. And so transform this. So this would be 1 minus cosine 2x over 2 raised to the power of 3 of dx. And so we can rewrite this again as 1 minus cosine of 2x raised to the power of 3 over 2 raised to the power of 3, which is 8. So this would be 1/8 integral of 1 minus cosine of 2x raised to the power of 3 of dx. Next step is to expand this expression. So we would have 1 minus 3 cosine of 2x plus 3 cosine squared of 2x minus cosine cube of 2x dx. Now first, let us try to focus on this one first. Let us just exclude this for the time being. So, if we are going to focus on here, this would be 1/8 integral of 1 minus 3 cosine of 2x plus 3 cosine squared of 2x dx. So we shall transform cosine squared 2x in this form. Wait, let me just make some space here. So this would be 1/8 integral of 1 minus 3 cosine of 2x plus 3 multiplied by 1 plus cosine 2 x here is 2x over 2 of dx. 2 multiplied by 2x would be equal to 4x. And multiplying 3 amongst this, we would have 3 plus 3 cosine of 2x. And so splitting this fraction apart, we would have plus 3 over 2 plus 3. Wait, let me just rewrite this. There we go, we have that. And so we can add 1 and 3 over 2, which would be equal to 5 over 2. Minus 3 cosine of 2x plus 3 cosine, wait, you can just put this as 3 over 2 cosine 4 of x dx. So let us focus on here first. In this case, let u here be 2x. Derivative of 2x would be 2 dx. And so dx right here would be equal to du over 2. Integral of 1/8 integral of 3. Wait, we can put 3 outside. So this should be 3 over 8. Cosine 2x here is u, and dx right here would be equal to du over 2 plus 1/8 integral of 3/2 cosine to the power of 4 of x dx. And so we can now focus on this one next. Let a here be 4x. Derivative of 4x would be 4 dx. And so dx would be equal to dA over 4. So this would be cosine of u multiplied by dx, which is, wait, a, dA over 4. 4 times 2. Wait, let us simplify this. 3/2 multiplied by 1/8. This would be 3 over 16. And multiply 16 by 4, which would be 64. And so what you're left with here is cosine of a dA. Multiply 2 outside. So this would be 3 over 16. Now that we have this simplified expression, we can now start integrating this. For this one, the integral of this would be 5 over 16 of x minus 3 over 16. Integral of cosine of u is simply sine of u plus 3 over 64. Integral of cosine of a is sine of a. And it is not necessary to add plus c here because we still have this one expression. And so the answer here, let us put it this way first. 5/16x minus 3/16 sine u here is 2x plus 3/64 sine of a, which is 4x. And this is now the answer for this particular part. And now, since we have this part, we can now focus on cosine cube of 2x dx. So what we're left with here is negative cosine cube 2x. Let me just rewrite this. This would be 1/8 integral of, this should be negative since this is negative, integral of cosine cube of 2x dx. Now, since this is an even exponent, we can use the even rule earlier, but that only applies if it is simply x, but we have here is 2x. So what we're going to do here is to substitute it into a simpler form. Let u here be 2x, this one, and so derivative of 2x is 2 dx. Dx right here would be equal to du over 2. And so this would be negative 1/8 integral of cosine cube of u. Dx right here would be equal to du over 2. And so put 2 outside the integral, and you would have 1/16 of integral of cosine cube u of du. Now this looks like the even rule earlier. Now what we're going to do here, if you still remember, is to factor out 1 cosine of u. So this would be cosine squared of u multiplied by cosine of u du. So transform this into its identity. So we would have negative 1/16 integral of 1 minus sine squared of u cosine of u du. Let me just make some space here. And now let a here be sine of u. So derivative of this would be cosine of u du. Now what we are left here with is negative 1/16 integral of 1 minus a squared cosine u du is equal to dA, which is this one. And now we can integrate this. This would be negative 1/16 integral of 1 dA is a minus a cube over 3 plus c. And so by substituting it now, we would have this one, negative 1/16. A here is sine of u, and u here is 2x. Since this is negative and this is negative, this would be positive 1/16. A cube here is sine cube of u, which is 2x over 3. And so 16 times 3 would be equal to 48. So this would be 1/48 sine cube of 2x plus c. And so this will be the final answer regarding this expression. Wait, let me just clean this. Now, what we're going to do here is to combine our answer. let's just put this into this. And so what we have here is negative 1 over 16 sin⁵x plus 1 over 48 sin³ of 2x plus c. But this is not yet the final answer because there are still common term here which we shall add. We have here a sine of 2x and sine of 2x. So we must add their coefficients, which is negative 3 over 16 and negative 1 over 16. So this would be equal to negative 4 over 16, or simply 1/4. Plus 3 over 64 sine of 4x plus 1 over 48 sin³ of 2x plus c. And this is finally the final answer regarding integral of sine to the power of 6x. We can now continue on with the integral of cosine² of x dx. Now, for this one, we will use this formula. And so this should be the integral of 1 plus cosine twice of x, which is x in this case, over 2 of dx. And so we can put 2 outside. So this should be 1/2 the integral of 1 plus cosine of 2x dx. Let u here be 2x. Derivative of 2x would be 2 dx. And so value of dx here would be equal to du over 2. And now let us substitute. We would have 1 over 2, the integral of 1 plus cosine of u. Dx right here would be equal to du over 2. Thus, putting 2 outside the integral again, we would have 1/4 integral of 1 plus cosine of u of du. By integrating this, integral of 1 du would be simply u. And the integral of cosine of u would be sine of u. Thus, the final answer would be 1/4 u here is 2x plus 1/4 sine of 2x plus c. Or you can cancel this, which will be left to 2. And so this would be simply x over 2. The integral of cosine to the power of 4 of x. So we will convert this first to cosine² of x. 4 divided by 2 would be 2. And so, next step will be to transform into this formula. We can write this again in this form. Two squared right here would be equal to 4. So we can put that outside. Next step will be to expand this expression. So this should be 1/4 the integral of 1 plus 2 cosine of 2x plus cosine squared of 2x. And so, as you can see here once again, we have a even exponent, so we will use this again. So this should be transformed to 1 plus cosine of 2x. Twice of x, I mean. But since we have here a 2x, this would be 2x over 2. 2 multiplied by 2x would be 4x. Wait, let me just rewrite this. So, we can split this fraction. We can use this as like this. This can be 1/2 plus cosine 4x over 2. And so, we can add 1/2 and 1, which would be 3 over 2. For simplification, we will split the integral apart. So this would be 1/4 integral of 3/2 of dx plus 1/4 integral of 2. Wait. We can put 2 outside now, so this would be 2 over 4 cosine of 2x. Simplify this, we would have 1/2. Plus, since we have a fraction of 2 here, we will put outside. So this would be 1/8 integral of cosine of 4x dx. Now let us focus on here first. Put 3/2 outside the integral. So 1 times 3 would be 3, 4 times 2 would be 8, and integral of dx would be simply x. So we are done in this part. So let us now focus on this one. In this case, let u here be 2x. So derivative of 2x would be 2 dx. And so dx right here would be equal to du over 2. Substituting this into this integral, we would have 1/2 integral of cosine of u, and dx right here would be equal to du over 2. So putting outside that 2, this would become 1/4 cosine of u du. Now we can focus on this last part. Let a here be 4x. So derivative of a, which is 4x, is 4 dx. Dx right here. Dx right here would be equal to dA over 4. And so this would be plus 1/8 integral of cosine of a. Dx is dA over 4. 8 multiplied by 4 would be equal to 32. Now we can simply integrate the rest. Integral of cosine of u would be simply sine of u. Plus integral of cosine of A is sine of A. Putting back the variables in their original form, the final answer would be 3x over 8 plus 1/4 sine u here is 2x plus 1 over 32 sine of 4x plus c. The integral of cosine to the power of 6 of x. So, we will put it in the form of cosine of x, cosine squared of x. 6 divided by 2 would be 3. And transform this. And we can rewrite this. 2 to the power of 3 would be 8. Next, we can expand this expression. So this would be equal to 1 plus 1 plus 3 cosine of 2x plus 3 cosine squared of 2x plus cosine cube of 2x. Now, just like with sine earlier, we can split this. We will split it in that way. So this is part 1. So this would be part 2. Now, since we just split this integral for further simplification, the answers for this 2, we'll just add it together later. So, focusing on this first, you can see here, we have an even exponent again, so we will transform this. But since we have a variable 3 here, we will multiply it all by 3. With 2 twice of x, which is 2x. 2 multiplied by 2x would be 4x. And so this would be 1/8 integral of 1 plus 3 cosine 2x plus 3 over 2 plus cosine of 4x over 2. Add 3 halves and 1, which is 5 over 2. For further simplification, we will split this one by one. Plus 1/8 of 3 cosine. Wait, since it has a variable 3, we can just put 3 outside. So this can be 3/8 cosine of 2x. Wait, this should be 3. Plus 1/8 integral of 3 cosine 3/2 cosine of 4x. Multiply 3/2 by 1/8, we would have 3/16. Of cosine of 4x. Dx. And so, focus on this one first. 1/8 multiplied by 5/2 would be 5/16. And the integral of dx would be x. So we are done. Focus on the second one. Let u here be 2x. Derivative of 2x would be 2 multiplied by dx. Dx would be equal to du/2. So this would be 3/8 integral of cosine of 2x. Cosine of u, I mean. Dx right here would be du/2. Multiply 2 and 8, we would have 16. Plus 3/16 integral of, focus on this one, let a here be 4x. dA would be 4 dx. Dx right here would be equal to dA/4. So this would be cosine of a. Dx would be dA/4. Multiply that by 16. We would have 64. So we can integrate this one by one now. Integral of cosine of u would be sine of u. Integral of cosine of a would be sine of a. There is no need first to put plus c, because remember we still have this other one. And so by putting the variables into their form now, we would have the answer of 5/16 of x, or this can be 5 of x over 16 plus 3/16 of sine u here is 2x plus 3/64 sine a here is 4x. And so this is the answer for this particular integral. So let us now go on to this one. Focusing on 1/8 cosine cube, since it has an odd exponent, we will use the add rule. But first, for simplification, that only works when you have a variable of x, not 2x. So what we're going to do here is to substitute it. Let 2x right here be u. And so derivative of 2x would be 2 dx. And so by substitution, we'd have 1/8 integral of cosine cube of u. Dx would be du/2. Multiply 2 by 8, we would have 1/16. Just remember, in the odd exponent, we would have a singular variable, not like 2 of x. It is acceptable if it's only x. But since it is 2 of x, we would have to do a substitution. And so we can finally use the add rule. So we can factor out cosine of x, cosine of u, I mean. And so transform this into its trigonometric identity, which would be 1 minus sine squared of u. And so let a here be sine of u. Derivative of sine would be cosine of u du. So this would be 1 over 16 integral of 1 minus u squared of du. Wait, this should be a, I mean. And so by integrating this, integral of 1a, 1 dA would be a minus a cube over 3. And now we can put plus c. Putting back a into its original form, we would have 1 over 16. A here would be sine of u, and u here is 2x, minus 1 over 16 multiplied by 3 would be equal to 48. And a here is sine cube of 2x plus c. And so we have now our answer for this integral. What we're going to do here next is to simply add these two together. Let me just put this. And now we have a common term here, which is sine of 2x. So add 3 over 16 and 1 over 16, which is 4 over 16, or 1/4. Sine of 2x plus 3 over 64 sine of 4x minus 1 over 48 sine cube of 2x plus the constant of integration. Integral of sine squared of x cosine squared of x dx. And now, when you're dealing with sine and cosine here, but the exponent are both even, just transform this into their corresponding formula. So, this can be sine squared of x corresponds to 1 minus cosine twice of x over 2. Multiply this by cosine squared of x, which would be 1 plus cosine of 2x over 2 dx. Multiply these two together, you would have 1 minus cosine squared of 2x over 4 of dx. So this can be 1/4 integral of 1 minus cosine squared 2x dx. You can see here, this man has an even exponent, so transform this. This can be 1/4 integral of 1 minus 1 plus cosine of cosine 2 multiplied by its x value, which is 2x. So this would be 4x over 2 dx. One minus 1/2 would be simply positive 1/2. And so, split this integral apart, we would have 1/4 integral of 1/2 dx plus 1/4. Wait, since we have 2 here, this can be 1/8 integral of cosine of 4x dx. Focus on here first. 1/4 times 1/2 would be 1/8. Dx right here would be x. Integral of dx, I mean. Plus 1/8 integral of. Focusing on the second one, let u here be 4x. Derivative of 4x would be 4 dx. So this would be cosine of u. Dx is du over 4. Multiply 8 and 4, you would have the value of 32. And so, integral of cosine of u would be sine of u. So, the final answer for this particular integral would be x over 8 plus 1 over 32 sine u here is 4x plus c.